In today's world, computer networking is an essential part of our daily lives. From the internet to local area networks, devices are connected and communicate with each other seamlessly. But have you ever wondered how this communication takes place? How does data travel from one device to another? The answer to these questions lies in OSI reference model. The OSI reference model is a conceptual framework that describes how data moves from one device to another in a network. Developed by the International Organization for Standardization, the model consists of 7 layers, each with its own set of functions. That being said, hello everyone, welcome to yet another technical session by Intellipaat YouTube channel. With today's session, we are going to unscrew all the intricate details of the networking concept known as OSI reference model. But before we begin with that, make sure to enable both the subscribe button and bell icon so that you never miss any update coming from our team. First of all, we shall discover the agenda for this session. We will begin this session on a very friendly note by getting introduced to the term OSI reference model. Then we shall talk about why this model matters and how it facilitates data communication. Finally, we shall cover the 7 layers of OSI model. I hope all of you guys are clear with the agenda.
So without wasting any time, let's get started with the first topic of our agenda, that is Introduction to OSI reference model. In the world of computer networking, the OSI reference model is a term that is often heard but not always understood. It is a conceptual framework that describes how data moves from one device to another in a network. The model is designed to standardize network communication protocols and provide a common language to networking professionals to communicate and troubleshoot network issues. The OSI reference model consists of 7 layers, each with its own set of functions. The first layer is the physical layer, which deals with the physical transmission of data. This includes the cables, connectors, and other physical components that enable data to travel between devices. The second layer is the data link layer, which is responsible for error-free transmission of data. It corrects errors that occur during transmission and ensures that data is received correctly. The third layer is network layer, which provides logical addressing and routing. This layer determines the best path for data to travel from one device to another, taking into account factors such as network congestion and the destination of the data. The fourth layer is the transport layer, which manages end-to-end communication. It ensures that data is delivered to the correct application on the receiving device and manages flow control to prevent overload of the network. Now coming to the fifth layer, it is session layer. This layer establishes, manages and terminates connections. It ensures that data is delivered reliably and that both devices are aware of the connection status. The sixth layer is the presentation layer, which handles data translation and encryption. This layer is responsible for ensuring that data is presented in a format that can be understood by the receiving device, regardless of the type of device or software being used. The final and seventh layer is application layer, which provides services to end users. This includes applications such as web browsers, email clients, and other softwares that users interact with directly. The application layer communicates with the lower layers of the OSI reference model to ensure that data is transmitted correctly and efficiently. The importance of the OSI reference model lies in its ability to standardize network communication protocols. By providing a common language for networking professionals to communicate and troubleshoot network issues, it enables devices from different manufacturers to communicate with each other seamlessly. This is crucial in today's interconnected world where devices from different manufacturers and with different capabilities need to communicate with each other in order to provide the services that users do expect. The OSI reference model also provides a framework for the development of networking devices that are interoperable with other devices in the network. By following the standards set out In the model, manufacturers can ensure that their devices will work with devices from other manufacturers, making it easier for users to connect and use a variety of devices in their network. To sum up the basic notion, the OSI reference model is a vital tool in the world of computer networking. Its standardization of network communication protocols and provision of a common language for networking professionals has enabled the seamless communication between network devices. Now, moving forward, we shall discover why this OSI model matters so much and what are the reasons that it's there regulating the communication over networks. Basically, guys, the OSI reference model matters for quite a few reasons, including its ability to standardize network communication protocols, facilitate interoperability between devices, and provide a common language for networking professionals to communicate and troubleshoot network issues. OSI reference model provides the schematics for network design and implementation by breaking down the communication process into 7 layers. The model provides a clear and logical framework for designing and implementing networks. This enables networking professionals to design networks that are more efficient, scalable, and secure. Furthermore, the OSI reference model serves as a basis for other networking models such as TCP/IP model. The TCP/IP model is a simplified version of OSI reference model that is widely used in the internet and many other networking applications. Understanding the OSI reference model is therefore important for understanding the TCP/IP model and other networking models that are based on it. The OSI reference model matters because establishing standard communication protocols is key to formalizing communication across internal and external networks such as the cloud or the internet. Such standardization facilitates faster communication between devices and networks, irrespective of where the data resides, where it is sent, or from where it is received. The OSI model allows equipment manufacturers to define their standards and protocols while maintaining interconnectivity with other manufacturers. Moreover, the OSI model is key to troubleshooting network devices. When a networking unit fails, or an application goes down and cannot communicate with the rest of the network, the OSI model is handy as it allows administrators to zero in on specific OSI layer and troubleshoot the failed component. Thus, the conceptual OSI framework is crucial for designing, manufacturing, and troubleshooting network technology. I hope now you guys are familiar with the reasons for the need of this network standardization. Now moving forward, let me explain you guys how the OSI model standardizes data communication over the network. We'll actually do that with the help of an example. Let's imagine that you want to send an email from your laptop to a friend's smartphone. The email contains text, images, and a video clip. The first layer of the OSI reference model is the physical layer, which defines the physical characteristics of the network, such as cables and connectors used to transmit data. So, in case of our example, the physical layer would include the wireless connection between your laptop and your friend's smartphone. The second layer is the data link layer, which provides a way for a device to communicate with each other over the physical layer. This layer is responsible for breaking the data into smaller units called frames and adding error checking information to each frame. In our example, the data link layer would be responsible for breaking the email into frames and adding error checking information to ensure that the data is transmitted correctly. Now, the third layer is the network layer, which is responsible for routing data between devices on different networks. In our example, the network layer would be responsible for routing the email from your laptop to your friend's smartphone across the internet. Now, the fourth layer is the transport layer, which is responsible for ensuring that data is transmitted reliably and efficiently. In our example, the transport layer would be responsible for ensuring that all of the email's components, including text, images, and video, are transmitted correctly and efficiently. The fifth layer is the session layer, which is responsible for managing connection between devices, right? In our example, the session layer would be responsible for establishing and maintaining the connection between your laptop and your friend's smartphone. The sixth layer is presentation layer, which is responsible for translating data between different formats. In our example, the presentation layer would be responsible for ensuring that the text, image and video in the email are correctly formatted for display on your friend's smartphone. Finally, the seventh layer is application layer, which is responsible for managing user application and data. In our example, the application layer would be responsible for managing the email application and ensuring that the email is sent and received correctly. As you can see from this example, the OSI reference model facilitates data communication by breaking down the communication process into a series of layers or steps, each with its own set of functions. By doing so, the model ensures that data is transmitted efficiently and accurately across the network, enabling devices and applications to communicate with each other seamlessly. Next thing on our agenda is talking about the details of these 7 stages of OSI reference model. By now, we have seen how these layers function in the case of sending email from one device to another device over a network. Now let me tell you a little more about the functionalities of these layers one after another. Let's begin with the physical layer. The lowest layer of the OSI reference model is the physical layer. It is responsible for the actual physical connection between the devices. The physical layer contains information in the form of bits. It is responsible for transmitting individual bits from one node to the next. When receiving data, this layer will get the signal received and convert it into zeros and ones and send them to the data link layer, which will put the frame back together. The tasks that have been assigned to this physical layer are bit synchronization, bitrate control, physical topology and transmission mode specification. Let me tell you what these 4 terms simply mean. First, let's start with bit synchronization. The physical layer provides the synchronization of the bits by providing a clock. This clock basically controls both sender and receiver, thus providing synchronization at bit level. Next thing is bitrate control. The physical layer also defines the transmission rate, that is the number of bits sent per second, and it also specifies the physical topology. It basically specifies the way in which the different devices or nodes are arranged in a network, that is bus, star or mesh topology. The fourth task is transmission mode. Physical layer also defines the way in which data flows between the two connected devices. The various transmission modes possible are simplex, half duplex and full duplex. Now next, let's talk about data link layer. The data link layer is responsible for the node-to-node delivery of the message. The main function of this layer is to make sure data transfer is error-free from one node to another over the physical layer. When a packet arrives in a network, it is the responsibility of DLL to transmit it to the host using MAC address. Data link layer is divided into 2 sublayers, logical link control and media access control. The packet received from the network layer is further divided into frames depending on the frame size of NIC, that is your network interface card. DLL also encapsulates sender and receiver's MAC address in the header. The receiver's MAC address is obtained by placing an ARP request onto the wire asking who has that IP address, and the destination host will reply with this MAC address. The function of data link layer are framing, physical addressing, error control, flow control, and access control. Now let's start with framing and physical addressing. Framing is a function of data link layer. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. This can be accomplished by attaching special bit patterns to the beginning and end of the frame. Now then we have physical addressing. So basically, after creating frames, the data link layer adds physical address, that is MAC address of the sender or receiver in the header of each frame. Next is error control and flow control. Data link layer provides the mechanism of error control in which it detects and retransmit damaged or lost frames. Also, the data rate must be constant on both the side, else the data may get corrupted while the flow of data is going on. So, the flow control mechanism coordinates the amount of data that can be sent before receiving an acknowledgement. So, basically, it will control how data flows from one device to another device over a network. Then comes access control. When a single communication channel is shared by multiple devices, the MAC sublayer of the data link layer helps to determine which device has control over the channel at a given time. So what that will do is it will allow the linking of devices in proper manner so that the data may be transferred forward. Then third up we have is network layer. The network layer works for the transmission of data from one host to the other located in different networks. It also takes care of packet routing, that is, selection of the shortest path to transmit the packet from the number of routes available. The sender and receiver's IP addresses are placed in the header by the network layer. The functions of network layer are routing and logical addressing. Let's first talk about routing. The network layer protocols determine which route is suitable from source to destination. This function of the network layer is known as routing. Then comes logical addressing. In order to identify each device on internetwork uniquely, the network layer defines an addressing scheme. The sender and receiver's IP addresses are placed in the header by the network layer. Such an address distinguishes each device uniquely and universally. So that is why this layer is quite important when it comes to OSI model. Now let's talk about the heart of OSI model, that is the transport layer. This layer provides services to the application layer and takes services from the network layer. The data in the transport layer is referred to as segments. It is responsible for the end-to-end delivery of the complete message. The transport layer also provides the acknowledgement of the successful data transmission and retransmits the data if an error is found. At the sender's side, transport layer receives the formatted data from the upper layers, performs segmentation and also implements flow and error control to ensure proper data transmission. It also adds source and destination port numbers in its header and forwards the segmented data to the network layer. Generally, this destination port number is configured either by default or manually. For example, when a web application makes a request to web server, it typically uses port number 80 because this is the default port assigned to web applications. Many applications have default ports assigned. Now, coming back to the receiver side, the transport layer reads the port number from its header and forwards the data which it has received to the respective application. It also performs sequencing and reassembling of the segmented data. So basic functions of this transport layer are segmentation and reassembly and service point addressing. This layer accepts message from the session layer and breaks the message into smaller units. Each of these segments produced has a header associated with it. The transport layer at the destination station reassembles these messages. Then comes service point addressing. In order to deliver the message to the correct process, the transport layer header includes a type of address called service point address or port address. Thus, by specifying this address, the transport layer makes sure that the message is delivered to the correct process. Next, we are going to talk about the session layer. This layer is responsible for the establishment of connection, maintenance of sessions, authentication, and also ensures security. The functions of the session layer are session establishment, maintenance and termination, synchronization, and dialog controller. Let's talk about session establishment, maintenance, and termination, that is, handling everything about session. The layer allows the two processes to establish, use, and terminate a connection. Then synchronization is all about process of adding checkpoints which are considered as synchronization points into the data. These synchronization points help to identify the error so that the data is resynchronized properly and ends of the message are not cut prematurely and data loss is avoided. Similarly, dialog controller is there. The session layer allows two systems to start communication with each other in either half duplex or full duplex form. On that note, let's move on to the second last layer, that is the presentation layer. Presentation layer is also called as the translation layer. The data from the application layer is extracted here and manipulated as per the required format to transmit over the network. The functions of the presentation layer are translation, encryption, decryption, and compression. Let's first talk about translation. So basically here data gets manipulated into the desired format. The example of that will be converting a SCSI to EBCDIC format. Now, next thing is encryption and decryption. Data encryption translate the data into another form of code. The encrypted data is known as the ciphertext and the decrypted data is known as plain text. A key value is used for encrypting as well as decrypting the data in this case. Next is compression. Compression basically reduces the number of bits that need to be transmitted on the network. At the very top of the OSI reference model stack of layers, we find the application layer which is implemented by the network applications. These applications produce the data which has to be transferred over the network. This layer also serves as a window for the application services to access the network and for displaying the received information to the user. The examples of this will be all the web browser applications as well as Skype Messenger or Gmail. Guys, that's all we had for this session today. I hope this session was informative for all of you guys out there and now you're clear with this concept of OSI reference model and networking. Thanks for being here till the end of this video. If you have liked this video, do make sure to hit that thumbs up button and don't forget to subscribe to Intellipaat YouTube channel. Goodbye till next time.
Just a quick info guys, if you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job.